we are in part 1 of our problem sets. So, for number 1, we have here, if cosine theta is equal to 24 over 25, and theta is in the fourth quadrant, find the other 5 trigonometric functions of theta. So, to find the other 5 trigonometric function, we need to illustrate first. Let's draw a Cartesian plane. Then, since our theta is in fourth quadrant, and cosine is equals to adjacent over hypotenuse. So our adjacent here is 24 and our hypotenuse is 25. So we have here a missing side which is b, or our opposite. So we can use this equation to find our b. Our a squared is 24 plus b is unknown, and our c is 25. So if we solve this, we will get b squared is equal to 625 minus 76. Then put square at both sides to cancel out the squared exponent. So b is equal to 49. So square root of 49 is 7. Since our b is in the fourth quadrant, our b will be negative 7. So we have here our trigonometric functions of theta. So this one is the given, and sine theta is equals to opposite over hypotenuse. So our opposite is negative 7, hypotenuse is 25. Tangent theta is opposite over adjacent, so our opposite is 7, our adjacent is 24. Then our second theta is equals to a hypotenuse over our adjacent. There's a hypotenuse and this is our adjacent. Then our cosecant theta is equals to our hypotenuse over our opposite, which is negative 7. We have here 25 over negative 7. And for cotangent, theta is equals to adjacent over our opposite. So now, as you can see, these are the other 5 trigonometric functions of theta. Now, let us continue to our number 2. So we have here express secant theta minus sine theta tangent theta as a single function of theta. So we have here secant theta minus sine theta tangent theta. So to make this in a single function of theta, we need to transform secant theta and our tangent theta to sine and cosine form. So as you can see here, our secant theta here is 1 over cosine. So our secant theta is 1 over cosine minus our sine theta multiplied by our tangent theta. So our tangent here is sine over cosine. So we have here sine theta over cosine theta. Then we simplify, we will get 1 over cosine theta minus sine squared theta cosine theta. Third derivative, simplify again. The denominator will be cosine theta, then cosine theta divided by cosine theta is 1 times 1 is 1, and cosine theta divided by cosine theta cos 1 times sine squared theta, we will get sine squared theta. Then as you can see here, we have 1 minus sine squared theta. As you can see here, this one, if we transpose this to the other side, we will get cosine squared x equals to 1 minus sine squared x. So as you can see here, it's the same. So we can write it as cosine squared x. Then we have here cosine squared x over cosine theta. Then if we divide, we will get cosine theta. So the single function of theta is cosine theta. Now for our number 3, we have here express tangent squared x minus secant squared x in terms of sine x and cosine x, and simplify. So we have here our tangent squared x minus secant squared x. So first we need to put this in sine x and cosine x. So our tangent squared x is, you can see here, tangent is sine x over cosine x. Since it is squared here, so we can write it as sine squared x over cosine squared x minus our secant squared x is, our secant is 1 over cosine, and since it is squared here, we can write it as 1 over cosine squared x. Then we can simplify. Now, so as you can see, we have the same denominator, so we can copy it and copy our numerator. Then as you can see, we have here sine squared x minus 1. So as you can see, this equation, we can write it as sine squared x, then transpose this to the other side. So we'll get and transpose onto the other side. So negative 1 equals to negative cosine squared x. So you can see here and here. Just transpose, you will get here. So we have here sine squared x minus 1. Just like here, we have sine squared x minus 1. So this equals to negative cosine squared. So we have here negative cosine squared. Then if we simplify this, we will get negative 1. Now we are in number 4. So we are asked to find the exact value of our cosine 5 pi over 12. So as you can see here, have our cosine 5 pi over 12. So first, what we're gonna do is to convert our 5 pi over 12 into a degree. So to do that, we multiply it by 180 degrees over pi 180, because our half of a circle is 180 degrees. So as you can see, we can cancel out our pi. Then we can multiply 5 times 180 degrees is equal to 900 degrees over 12 times 1 is 12. So we have here cosine 900 degrees over 12. Then 900 divided by 12 is equals to 75. So we have cosine 75 degrees. And to find the exact value, we can plug in. So cosine 75 is equals to 2558190,451, or we can write it or round off. So we have here 0.2552588. So to continue, we are in number 5. So we are asked to express a cosine 270 degrees minus theta, and b tangent pi plus x as function of theta of x alone, or x alone, or. So for our a, we have here our cosine 270 degrees minus theta. So to express this, as a function of theta, we'll write our 270 degrees as the sum. So we will get here cosine 180 degrees plus 90 degrees minus theta. Then what we do now here is to transform this equation into expression. Transform the expression by using this equation here. Cosine 180 degrees plus t is equals to 1 cosine t. So in this case, our t is this one, 90 minus 90 degrees minus theta. So we have here now negative cosine 90 degrees minus theta, and after that we can also transform this by using this equation. Cosine 90 degrees minus t equals sine t. So our t now here is our theta. So since it's a sine, so we have here sine and sine theta, and because it is negative, so our answer will be negative sine theta. And for the b, we have here tangent theta, tangent pi plus x. So using commutative property, we can exchange. So have here now tangent x plus pi. So to express this as a function of x, we'll have here we can use this to transform our equation. So our tangent t positive negative k times pi is equals to tangent t. So our t in this case is x. So we have now here our tangent x as a function of x. So now we are in number 6. So we have here is a half angle identity to find the exact value of sine negative 22.5 degrees. So we have here, as you can see, negative 22.5 degrees. So what we're gonna do here is to multiply both sides by 2. So now we can cancel out 2 and multiply 22.5 by 2. We will get our theta is equal to negative 45 degrees. So now we can use the half angle formula. So this is the half angle formula, and if we plug in, we will get our 1 minus cosine negative 45 degrees over 2. So cosine negative 45 degrees is square root of 2 over 2. Then what we can do here is to multiply them by 2. So we will have here 1 times 2 is 2, and square root of 2 over 2, and we can cancel 2, and we will have square root of 2 over our 2 times 2 is equal to 4. Then if we use our calculator, we will get now the exact value of sine negative 22.5. As you can see, I just plug in this one here in the calculator, and answer is negative 0.38268. So if we round off, we will get negative 0.3827. So if you want to check, you can do sine negative 22.5 degrees. As you can see, they have the same answer. Now we are in number 7. So here, given that sine A is equals to 5 over 13 and cosine B is equal to negative 3 over 5. So A is a quadrant 1 and B is a quadrant 2 angle. So find each following. First is sine A plus B, second cos A plus B, and third tangent A minus B, and lastly the quadrant of A plus B. So to find the following, we need to illustrate first. So as you can see here, this is D, A, and 5, because sine A is equals to opposite over hypotenuse. So our opposite is 5 and our hypotenuse is 13. So we need to find this side. So to find this side, we use this formula, that a squared plus b squared equals c squared. So our a is unknown, so x squared plus 5 squared is our opposite, and our hypotenuse is 13 and squared. Then x squared is equal to 13 squared minus 5 squared, and we will get x squared equals to 169 minus 25. Then we will get 144, then square both sides, and we will get x is equals to 12. So now we have our x. Next, we have our cosine b, and cosine is equals to adjacent over hypotenuse. Our adjacent is here -3 and our hypotenuse is 5. Again, to find the missing side, we need to use this formula. So we have your -3 squared plus y squared equals 5 squared. So -3 squared is 9 plus y squared equals 25. So y squared equals 25 minus 9. So 25 minus 9 is 16. Then we squared both sides. So now we have here our y, which is 4. Now we have 4. Now we can find the sine quantity a plus b. So sine a plus b is equals to sine a cosine b plus minus cosine a sine b. So our sine a is 5 over 13. Our cosine b is -3 over 5 plus our cosine a, which is cosine a is adjacent over hypotenuse. So our adjacent is here, which is 12, and hypotenuse 13, and our sine b is here, opposite, and our hypotenuse here. So if we simplify, we will get -15 over 65 plus 48 over 65. Now we can calculate. So our sine a plus b is equals to 33 over 65. Up next, to solve for our b, we have here cosine a plus b. So cosine a plus b is cosine quantity a plus minus b is equals to cosine a cosine b minus plus sine a sine b. So our cosine a is 12 over 13. Our cosine b is -3 over 5 minus, because it is plus here, so we need to subtract. So our sine a is 5 over 13. Our sine b is 4 over 5. Then we simplify. So we have here -36 over 65 minus 20 over 65. Then we have here our cosine a quantity a plus b is equals to -556 over 65. Next, we have here our tangent quantity a minus b. So tangent quantity a plus minus b is equals to tangent a plus minus tangent b over 1 minus plus tangent a tangent b. So our tangent a is opposite over adjacent, so our opposite is 5 and our adjacent is 12, plus tangent b is 4 here at the opposite, and our adjacent is -3. plus over negative over 1 minus our tangent A is 5 over 12 and our tangent B is 4 over negative 3. So if you simplify, you will get negative 11 over 12 over 1 minus 20 over negative 36. Then if we simplify, simplify, we will get negative 11 over 12 over 1 minus negative 5 over 9, and this is equal to negative 33 over 56. So our tangent A minus our tangent quantity A minus B is equal to negative 33 over 56. So thus cosine A plus B has negative value, right? And our sine A plus B has positive value. That means our x is negative and our y is positive. Therefore, we can say that quadrant of A plus B is at a second quadrant. Now we are in part 2, and we need to verify that each equation is an identity. But before we solve, we need to remember this. Sine squared x plus cosine squared x is equals to 1. And 1 plus tangent squared x is equals to secant squared x. And 1 plus cotangent squared x is equals to cosecant squared x. And cosine squared t minus sine squared t is equals to cosine 2t. And tangent x is equal to sine x over cosine x. Cotangent x is equals to cosine x over sine x. Tangent x is also equal to 1 over cotangent x. And secant x is equals to 1 over cosine x, and cosecant x is equals to 1 over sine x. Now, for our problem 9, we have here secant squared b is equals to 1 over 1 minus sine squared b. So, to verify, we separate the secant squared b. So, it is going to become secant squared b, and secant squared b is equals to 1 over 1 minus sine squared b. So, our secant b here is, as you can see here, secant is equals to 1 over cosine x. So, we have here 1 over cosine b because it is b here. So, 1 over cosine b, and multiplied by 1 over cosine b is equals to 1 over 1 minus sine squared b. Then, if we combine, we will get 1 over cosine squared b equals to 1 over 1 minus sine squared b. So, cosine squared b has cosine squared b, as you can see here, this one. We have your cosine squared, right? Then if we transpose sine squared x to the other side, we will get cosine squared x is equals to 1 minus sine squared x. So now we have here 1 over sine squared 1 over 1 minus sine squared b is equals to 1 over 1 minus sine squared b. So we can say that they are equal, so it is verified. Now we are in number 10, and we have here cosine 2a is equals to cotangent a minus tangent a over cosecant a secant a. So to solve this, first I saw this area. So cotangent a as you can see here, is cotangent x equals to cosine over sine x. So we have here now, this is cotangent A, and this is cotangent A now, so it is equal to cosine A over sine A, minus tangent A. So tangent A here is that the tangent x is equal to sine x over cosine x. Now, tangent A is equals to sine A over cosine A over cosecant A. So our cosecant here, our cosecant here is here. This is supposed to be C. So our cosecant here is 1 over sine x. So now I put here 1 over sine A. Multiply by our secant A. So our secant here is 1 over cosine x. So we can write 1 over cosine A. Now, we can solve and simplify. So their denominator will be this sine A multiplied by cosine A. So if we have here sine A cosine A divided by sine A, we can cancel out sine A and multiply cosine A to cosine A. So we will have cosine squared A. Then if we divide sine A cosine A to cosine A, we can cancel cosine A and we will get sine A, and if we multiply sine A, we will get sine squared A over multiply 1, we have here 1, and sine A multiplied by sine A cosine A. So now we can cancel out this, and we will have cosine squared A minus sine squared A over 1, or we will have here cosine squared A minus sine squared A, then copy this here. Now we have here cosine 2A equals to cosine squared A minus sine squared A. So cosine squared A minus sine squared A, we can put it in this form. So cosine squared t minus sine squared t is equals to cotangent to t. So our t here na is A. So we can say that cosine 2A is equals to cosine 2A. So they are now the same. So we can say they're equal, and it is verified that it is an identity. So here, number 11, we have tangent squared x minus sine squared x is equal to quantity tangent x sine x squared. So we transform tangent squared x into cosine and sine form. So tangent squared x is equal to sine here, sine over cosine. So since it is squared, we can put it outside, right? Now we will now have here sine x over cosine x squared minus our sine squared x is equals to, here our tangent x is equals to sine x over cosine x, right? Multiply by sine x, then squared. Up next, we can simplify this. So we will get the limiter will be cosine squared x. The cosine squared x divided by cosine squared, because we have squared here, is equals times sine x is equals to sine squared x minus cosine squared x multiply by sine squared x. So we get cosine squared x times sine squared x. So we can now factor. So we will get 1 minus cosine squared x. That's our here. We have sine here and minus cosine squared x. So we can factor and put sine squared x outside and over cosine squared x. So 1 minus cosine squared x, as you can see here, we can say that this is sine, because if we transpose this on the other side, we will get 1 minus cosine squared x. So now we can write it as sine squared x multiplied by sine squared x over cosine squared x. So if we simplify, we will get sine raised to 4x cosine squared x. Then since we have this, we can write it here. Then solve for this one, the tangent x sine x squared. So we can simplify this here, this one here. Simplify this, so sine x multiplied by sine x is equal to sine x squared over cosine x. Then since we have square here, we can simplify, so we will get sine raised to 4x over cosine squared x. So as you can see, they are equal, so we can say that it is an identity. So this number 11 is verified. Now we are in number 12. So we have here tangent x minus cotangent x over tangent x plus cotangent x equals to 2 sine squared x minus 1. So our tangent x here, as you can see, our tangent x is equals to sine over cosine x, and our cotangent x is equal to cosine x over sine x. So you can write cosine x over sine x here over our tangent x again is sine x over cosine x plus our cotangent x is equals to cosine x over sine x. Now we can simplify this. So we can solve the numerator first. Here the denominator will be cosine x sine x. So cosine x sine x, if we divide this to cosine x, cancel out the cosine x, then multiply sine x. Sine x, we will get sine squared x minus sine x, cosine x sine x divided by sine x. We can cancel out sine x, and we can multiply cosine x to cosine x, so we will get cosine squared x. Now the denominator, when we add them, their denominator will be cosine x over sine x. So cosine x sine x multiply divided by cosine x will be sine x. Then we multiply sine x to sine x, we will get sine squared x. Next, cosine x and sine x divided by sine x, we can cancel this one and what left is cosine x, and we multiply cosine x, so we get cosine squared x. So we can cancel out this as the same denominator. So we have now sine squared x minus cosine squared x over sine squared x plus cosine squared x. So as you can see here, we have sine squared x plus cosine squared x. So sine squared x plus cosine squared x is equals to 1, right? So we now have sine squared x minus cosine squared x over 1. So if we simplify, we will get sine squared x minus cosine squared x. Now since we have this, we can write it here because we solved this. We have sine squared x here minus cosine squared x equals to this one, copy, 2 sine squared x minus 1. So we can put negative outside, so we are left with 1 minus 2 sine squared x. So as you can see here again, if we transpose this sine squared x to the other side, we will get cosine squared x equals to 1 minus sine x, just like this one. So we can say that 1 minus 2 sine squared x is equals to negative cosine 2x. So here now you have sine squared x minus cosine squared x, so we can put negative outside 2. We can have here positive. No need na pala. So we have here cosine squared x minus sine squared x. As you can see here, this one, we have cosine squared t minus sine squared t is equals to cosine 2t. We have here now wait, we need to put negative outside because cosine is negative and our sine is positive, so we just binaliktad lang. So we will have now here negative cosine 2x, so we have here negative cosine 2x equals to negative cosine 2x, so negative cosine 2x is equals to negative cosine 2x, so we can say that this is an identity, and it is true that tangent x minus cotangent x over tangent x plus cotangent x is equals to 2 sine squared x minus 1. So this is number 12 is verified. So hello, so for part 3 we're going to solve each equation and give solutions in exact form. So for number 1, we have here 3 ln x is equals to 13. So first I did here was I cancel the 3 and divide this side by 3, and I will get ln x is equals to 13 over 3. Then after this I put this in exponential form. It's going to be this is supposed to be ln, so ln base a of n is equals to x, and it's going to become n is equals to a raised to x. Our n is our x, here, here, and our x is 13 over 3, and our a is e, since this is a natural log. Then we will get our answer is equals to x is equals to 13, our e is equals to e raised to 13 over 3, or cube root of e raised to 13. For number 2, we have here log of 2x plus 7 is equals to 0.25. So our what we're gonna do here again is to put this in exponential form. So to do that, we are going to follow this log base of a of n is equals to x, and it's going to become n is equals to a raised to x. So we have now here our 2x plus 7, since this is our n, equals to 10. Our 10 is our a, and 0.25 is our x. So now we can transpose our 7 here to the other side. Then we can cancel our 2 and divide this side by 2. So now we will get x is equals to 10 raised to 0.25 minus 7 over 2, or 4th root of 10 minus 7 over 2. Number 3, so we have here log base 2 of quantity x cubed plus 5 is equals to 5. So to solve this, we're gonna follow this equation, because we were gonna get log base a n is equals to x, and it's going to become n is equals to a raised to x. So our n is this one, x cubed plus 5, and our x is equals to 5, this one, and our a is 2, because it is a base. Then we can write it like this: x cubed plus 5 is equals to 2 raised to 5. And now we can simplify. So x cubed plus 5 is equals to 32. Then we can transpose our 5 to the other side. So we're gonna get x cubed is equals to 32 minus 5. So it is 27. So we cancel out the cube here, and we will get x is equals to 3. We just 27 cube, and we're gonna get x equals to 3. Now for number 4, we have log base 4 of quantity 3x plus 1 quantity x minus 4 is equals to 2. So first we're gonna simplify this one. So we're gonna get log base 4 of 3x squared minus 11x minus 4 is equals to 2. So we will gonna use again this formula to get our exponential form. So we have log base a of n is equals to x, and it's going to become n is equals to a raised to x. So our n is 3x squared minus 11x minus 4, and our x is 2, and our a is 4. So we can now write it like 3x squared minus 11x minus 4 is equals to 4 squared. Then we simplify, we will get 3x squared minus 11x minus 4 is equals to 16. Then we transpose 16 to the other side. We will get put this in 0. Then we have here 3x squared minus 11x minus 4 minus 16, and it's equal to 3x squared minus 11x minus 20 equals 0. So to get the x, we can use our calculator by using mode 5 and 3. Then we plug in. So we have here 3 then equals, we have negative 11 and negative 20. So our x sub 1 is equals to 5, as you can see, and our x sub 2 is negative 4 over 3. Now we have here for number 5, we have log x plus log of 13 minus 3x equals to 1. So we can combine these two because we have the same base and their base is 10. So to combine them, we use this equation, log a plus log b is equal to log ab. So log x, quantity 13 minus 3x is equals to 1. Then we have now, if we simplify, we have log 13x equals to 3x squared equals 1. So we put this in exponential form. So using again this equation, log n is equals to x, to n is equals to 10x. So why 10? 10 because this is a common log. Then we can write now 13x minus 3x squared equals to 10 raised to 1. Then if we simplify, we have 13x minus 3x squared equals to 10. Then we can transpose our 10 here and put this in 0. And we have now negative 3x squared plus 13x plus 10 equals to 0. Then what we can do now here is to find the x. So we have here negative 3 and 13 and 10. It's supposed to be negative 10. So this is negative, by the way. Here. Wait. This is negative 10. Then our x sub 1 is equals to 10 over 3, and our x sub 2 is equals to 1. So this is our final answer. So for number 6, we have here ln 6x is minus ln x plus 2 factors equals to ln 4. So what we're gonna do here is to first simplify this factor. So we will get ln 6x minus ln x plus 2 times 1 is equals to ln 4. Then we will get ln 6x minus ln x plus 2 is equals to ln 4. Then we can combine this since they have the same base. So we're gonna use this ln minus ln b is equals to ln a over b. Then we're gonna write this like ln quantity 6x, this is a, and this is a, this is x plus 2 in b, that is our b, and b is here, equals to ln raised to 4. Then we can write this, we can, because they have the same base, we can write this as 6x over x plus 2 is equals to 4. Then we can cross multiply, so we will get 6x equals to 4x plus 2. And then if we simplify, we get 6x equals to 4x plus 8. Then what we're gonna do here is to transpose this to the other side. So we'll get 6x minus 4x equals 8. So we have here now 2x equals 8. Then we divide both sides by 2, so we can cancel out. Then we have 8 over 2, so our x is equal to 4. So now for number 7, we have here ln 5x is equals to 16. So we write this in exponential form first. So using this equation, ln of n equals to x, 2 ln equals to e, because it is a natural log, is to x. Then we can write it now like 5x equals to e raised to 16. So we can now solve by dividing both sides by 5, and we can get our x. Our x is equals to e raised to 16 over 5, or we can simplify this and we get our answer. Wait. So we have here 1. So e is alpha, then raised to 16 divided by 5. We're gonna get here 17772 to 2.104. If we roll up this, we're gonna get 1777. That is our x. Now we are in number 8, and we have here ln x plus ln x cubed is equals to 12. So we can combine these two by using this equation. So ln a plus ln b is equals to ln ep. So we can write it now right like this. So we have ln quantity x times x raised to 3, and we will get ln x raised to 4. So now we have here ln x raised to 4 is equal to 12. So our we can now use this equation to make it in exponential form. So we have a ln of n equals to x, and we will get n is equals to e raised to x. So our n is our ln x raised to 4, and our 12 is our x. So you can write it down now like this. We have x raised to 4 is equals to e, because it is a natural log raised to 12. Then we portrait both sides to cancel out raised to 4. Then we will get x is equals to 4th root of e raised to 12. So if we write this in version form, we will get x is equals to e raised to 12 over 4. And our answer is equals to x is equals to e raised to 3. Number 9, we have here log base 3 of quantity x squared minus 9 equals to 3. So to solve this, we can use this equation, log base a of n is equals to x, then we will get n is equals to a raised to x. So our n is x squared minus 9 equals to our a. Our a is 3, which is the base, and our x is the 3. Then we have now here, if we simplify, we have x squared minus 9 equals to 27. Then we can transpose this the other side. So we will get x squared minus 9 minus 27 equals 0. Then if we simplify, we get x squared minus 36 equals to 0. Then if we factor this, we will get our x of 1 is 6 and our x of 2 is negative 6. So I use my calculator to factor this. So mode 5 3, then we input 1, then 0, then negative 36. As you can see, x of 1 is 6 and our x of 2 is negative 6. Now we are in number 10. So we have here ln e raised to ln x minus ln and quantity x minus 4 is equals to ln of 3. So we can solve this first here by using this equation. So our e raised to s is equals to x times ln of e. So we can write it like as ln, because it is our x is equals to ln x times our ln e. So we will get ln x of times 1. So it is ln of x. Then we can now solve. We have now ln of x minus ln of quantity x minus 4 is equals to ln of 3. So we can combine these two by using this equation. I have here ln of a minus ln of b is equals to ln quantity a over b. So our ln now is, our a is x here, and our b is x minus 4. So our ln x over x minus 4 equals ln 3. And since we have the same base, we can write it like this. We have now x minus 4 equals to 3. So if we cross multiply, we will get x equals to 3x minus 4. So if we simplify, we'll get x equals to 3x minus 12. And if we if we simplify this, we will get negative 2x is equals to negative 12. So divide both sides by negative 2 and we will get our x is equals to 6. Now for number 11, we have here log base 7 of 3x, quantity 3x plus 2 minus log base 7 of quantity x minus 2 equals 1. Then to solve this, we use this equation. Log base a of a plus log base a of b is equals to log base a of a over b. So we now have here log base 7 of our a, which is 3x plus 2, and our b is x minus 2 equals 1. Now we can solve this by using this equation again, which is log base a of n is equals to x, and we will get n equals to a raised to x. So our n is 3x plus 2 over x minus 1, x minus 2 rather, equals to our a is 7 and our x is 1. Then if we simplify, we will get 3x plus 2 over x minus 2 equals 7. Then if we cross multiply, we will get 3x plus 2 equals to 7. Quantity x minus 2, then simplify, we will get 3x plus 2 equals to 7x minus 14. Then if we transpose, we will get 14 plus 2 equals to 7x minus 3. So now we have here 16 is equals to 4x. Then we divide both sides by 4 and we will get x is equals to 4. So lastly, for our number 12, so we have here log base 16 of square root of x plus 1 is equals to 1/4. So we use again this equation to make our problem in exponential form. So we have here now the n, which is the square root of x plus 1 is equals to our a, which is 16, and our x is 1/4. Then we simplify 16 raised to 1/4 and we will get 2. Then we square both sides to cancel out the square root. Now we have here x plus 1 is equals to 4. So if we transpose 1 to the other side, we will get x is equals to 3.